Thank you, sir. H.E. Marshal Baduria, my fellow panelists, former chiefs, good afternoon. I've got two challenges. Firstly, 95% of what I wanted to say has already been said. And secondly, I stand between you and lunch. So I will keep it very, very short. As a fighter pilot, whenever somebody proposes design and development of a new aircraft, the first question or that comes to mind is, or you'll ask the designer, which is the radar, what are the sensors, how good is the sensor fusion, what is the max range of the radar, how good is the pilot vehicle interface. Nobody is going to ask him which is the engine you're fitted, how much is the thrust, what is the power you're giving. But the fact of the matter remains that today in aerospace design, it is the engine which remains at the pinnacle of development. Everything else has been designed, mastered, upgraded, but the design and development of an engine remains that ultimate aim, and which very few countries have mastered. And this is evident from the fact that today a number of countries have developed and designed fighter aircraft and produced them, put them in the air. But the countries that have designed an aero engine remain only a handful few, 5 as Gavankar brought out. And unfortunately, India today falls in that bracket of countries which has designed and developed an aircraft but has not been able to put an engine onto a fighter. The design efforts that have been put in for the Kaveri have already been brought out by Director GTRE. We are well aware of that. And therefore, we cannot call it a complete failure when you look at the kind of money that was spent. It is a fraction of what engine development costs. And the Kaveri derivative engine definitely will have its utilization on various RPA projects, various UAVs and other projects which are in the pipeline, both by DRDO and possibly in the private sector. So while I'm not the expert on aero engine design, why is it so difficult to design and develop an aero engine? First of all is the technological complexity of the entire D&D process. Director Gavankar have talked about materials, and one of the important aspects is the materials which form the building blocks of designing and developing an engine. And along with the materials comes the machining, the tooling, etc., to put into place how to use those materials to finally build those modules. And I just want to highlight, this is something I learned only in the recent past. For example, the turbine blades have small holes called cooling holes. And while we have the technology to make round holes, you use laser drilling to make those holes. For example, the GE 414 engine uses elliptical holes on its turbines. And that technology resides only with GE. So while we can make round holes on a blade, the technology to make elliptical cooling holes on a blade does not reside anywhere else in the world except maybe with GE. Or maybe Safran today, which Gavankar may testify to that. So it is small things like this which finally end up making the task of designing and developing an engine that much more difficult. Of course, you have things like ceramic discs, single blade crystals, bladed discs or bliss, which are also there. And these are technologies which we will have to master not necessarily on our own. The next aspect is the requirement of extensive infrastructure and testing facilities, which requires a fair amount of capital expenditure. And this is another challenge in the design and development of an engine. What is most important is, and which has been brought out by multiple speakers before, is to stay invested. And IAF is well aware of this. While we are aware of all the fighter programs that are going to go forward, the LCA Mark II, the AMCA, they will all be initially designed and developed around the existing engine, the GE 414. But the IAF is well aware of the fact that in the future, when you look at the entire life cycle of the aircraft, an indigenous aero engine is a no-brainer. Therefore, we need to stay invested, consider it a marathon and not a 100-meter dash. Even today, established players like Pratt & Whitney, General Electric, etc., if you look at the engine design that they're doing for the next generation air dominance fighter or the NGAD, are looking at timelines of 10 to 15 years to develop that engine, despite all the experience they have of designing and developing engines up to the 5th generation, which was talked about. So where do we stand today? While, like we mentioned, the Kaveri may not have met all the requirements, there are a number of applications that are there. We also talked about the joint ventures that HL has with Safran, developing the engine for the ALH. A number of them, over 300 of them flying in the services and the Coast Guard today. They are already on the way to designing the next generation of engines for the IMRH. So there is a fair amount of technology which has been achieved in the design and development of turboshaft engines for helicopter applications. And now is the time to step up our game and start designing a fighter engine for our future platforms. And I think there is a consensus on this. Air Marshal Mateshwaran also spoke about, Gavankar spoke about, everybody, that there is no other way forward but to do this in a collaborative manner with an international engine house. Who that international engine house is going to be, that is a decision which is going to be well above my pay grade. But there is no doubt, and in the Indian Air Force also we are well clear on this, that whatever we decide to do, it has to be in collaboration with somebody who's been part of the game for years together. It is very important that this whole process of indigenous or aerogen development is not taken as a full, complete problem statement, but needs to be broken down into subcomponents and identify the critical technology challenges. The critical materials that are required for building the blocks are large. I would say about 75 to 80% today are available in the country, being designed and developed by various companies, both in the public and the private sector. But it is that last mile of 20% materials which is not available today and which is something that we need to address. Hot-end components, hot-end technologies is a very crucial area. Director GTRE mentioned that how the International Engine House will contribute in this area, and that is why that collaboration becomes that much more important. He did mention testing facilities, and this is something that the Air Force has been talking about a lot of times because, having commanded AST and now being here as ACAS Plans, we see this very, very often that testing facilities are not available, especially for the smaller players. Specifically, when I speak of aero engines, we've been doing the Kaveri program. Director GTRE mentioned we have spent $250 million. But even today, we do not have our own high-altitude engine test facility. We don't have a flying test bed. And it's not only cost of money, but like he mentioned, it is a question of time. Every time you want to go there and use their facilities, you end up waiting for 1 or 2 years. So every time you go there, the program gets put back by 1 or 2 years. And this is something that needs a whole-of-nation approach, because establishing these testing facilities and this infrastructure requires capital expenditure. And that can come partly from the government and partly from industry. But it cannot happen on its own because it requires a fair amount of investment, and which is not going to be easy to come by. But this is something that we are seeing every day, day in and day out, especially when it comes to aerospace products, which require a high degree of certification and qualification. The test facilities are available are few and far between. They are either with the big players, they are with DRDO, they are with DPSUs, maybe to some extent with our BRDs. But the small guys do not have access to this, or they have a long queue to get into. And this is something that has to be addressed on a war footing if you want to attain true self-reliance. There is also a requirement to leverage our civil aviation sector and the huge orders that are there for necessary collaboration. Mr. Sukran Singh also mentioned that for the private industry, the orders count. And I don't know how many of you have seen the Tom Cruise movie called Jerry Maguire. He's the sports agent for a big sports athlete. And he puts forward some proposals and the athlete just says, show me the money. So that's what the private sector looks at. And just to put out a conservative estimate, some values were put by Gavankar. But over the next two decades, India, the civil and the military, is looking at procuring or replacing almost 2,000 aircraft, fighters, transport, helicopters, civil, military. And all of these over their life cycle will need thousands of engines. So the numbers are there, the money is there. It is somebody who has to bite the bullet and put in that money for the R&D. And I also want to highlight here that today, as part of MAKE and IDEX and TDF, we interact with all kinds of players. And we in the Air Force find that the small players, the MSMEs, are more reluctant agreeable to taking risks. And it is the big players who are a sort of reticent about taking a risk because maybe they have boards to answer to or they have shareholders. But the small guys are ready to take more risks as far as designing and developing a new product is concerned. And I think this needs to extend to the bigger players in the private sector also. Funding, of course, is absolutely necessary. Director GTRE mentioned how they have used only about $250 million. The Americans, for example, are designing their next generation of engine for their NGAD program, or the next generation air dominance fighter. They call it the next generation adaptive propulsion engine. And even today, they are looking at about $4 to $5 billion to design an engine, despite having developed up so many engines over the past years. So the funding is required, And I think whatever discussions we are having internally, the government is more or less convinced that this funding is required, and we will get this money, or DRDO will get this money to move ahead with this design and development. Another aspect which is very important from the Air Force's point of view is sustenance of existing platforms. All our platforms today are flying with various engines sourced from various countries. HAL has started doing or is doing license production of the AL-31FP. What we would like to see is to increase the IC content of these engines, do more and more stuff in India. We have to have sustenance packages for all our engines on the Jaguar, on the Hawk, on the MiG-29, everything going forward. And it is not only jet engines. We need to look at turboprop engines for the trainers. The STT-40, which is being bought, is still being powered by an imported engine. And it is not the same as the PC-7. So we will have two trainer fleets with two different engines. And this is something that needs to be addressed. So we need to look at turboprop engines, which will power the next generation of trainers, which will be designed and developed in India. And sustenance for our existing platforms is a very, very crucial issue for the Indian Air Force. And while we go in for this collaboration with an international engine house, we have to realize that whether it comes to engines or to aircraft, we are a generation behind the rest of the world. For example, the AMCA, which is going to fly in 28, hopefully, and will finish its D&D by 2034. And there are countries which have already started designing, and the Chinese supposedly having flown a 6th generation aircraft. So in terms of engine development also, we need to start including technologies which the world is working on into our program and not concentrate on just getting a 110 kilonewton engine with 5th generation technologies. So whether it is adaptive airflows to have an engine which can give you excellent fuel consumption during supercruise or during cruise, and at the, with a small change in the airflow, give you max thrust for combat, whether it is ceramic materials, thermal management. Today, for example, the F-35, there was a proposal to have a new engine in the later variants of the F-35, but the Americans have done away with it and said we will use the same core, improve the thermal management techniques to derive the same, more out of the same hot core without having to go into a full new engine development. And these are the technologies that we need to incorporate into whatever program that we put in place today, so that the engine we get 10 to 13 years down the line is contemporary and is not of a generation older as is the case today. So I would only expect that whatever plan decision is taken, takes into account these aspects, and there are equally good spin-offs to helping us to sustain our various fleets which are operating with various types of engines from various parts of the world. With that, I have finished. Thank you. Jai Hind.